Hi, this is Module 7, Lesson 1, Transformers, Shifty Wise. So Optima Prime is designing a robot quilt for her new grandson. She plans for the robot to have a square face. The amount of fabric that she needs for the face will depend on the area of the face. So she decides to model the area of the robot's face mathematically. She knows that the area of a square with a side length x units, which we can make whatever we want to make at the time, um, is modeled by the function a of x equals x squared square units. So what is the domain of this function given this context? Well, we know that if it's a square quilt, we can use real numbers because we can have partials, but we also know they have to be positive. So all positive real numbers. And so we can write that. We can also um, make put it in an interval form. Oh, we got to do it as a equation. So we can use the infinity symbol. But I might just write it. Um, so we can do interval notation. So goes to 0 all the way up to infinity, right? We don't want to include 0 because we don't want to have 0 um, length. Otherwise, it wouldn't be a square. The other way is set notation, where we have x and, oh, the x I want. 0 is less than x, which is less than or equal to, well, we don't probably want an equals to in there since it's infinity. There we go. All right, so that's kind of our 3 different ways we can write the domain. All right, so now we're going to match each statement about the area to the function that models it. So the length of each side is increased by 5 units. So the length of each side is, so we have an x, and we're going to add basically 5 units, 3, 4, 5, to each side. Well, so that's an x plus 5, x plus 5. And then we have to square it to get our area. So that makes it a b. The length of each side is multiplied by 5 units. Well, if the length of each side, this is one length, and we're going to do 5 of those, 1, 2, 3, 4, 5, and then we've got this one, 2, 3, 4, 5, to make our new 5x and 5x, then that would make this C right here. The area of the square is increased by 5 square units. So we've got the area of the square, and then we've got 5 units on the side. So that would be D, because we found the area, then we added 5. And the area of the square is multiplied by 5. So again, we have the area, and then we need to multiply it by 5 first. So this means we're going to square it first, then multiply it. Okay, Optima started thinking about the graph of y equals x squared in the domain of all real numbers and wondering about how the changes to the equation of the function, like adding 5 or multiplying, affect the graph. She decides to make predictions about the effects and then check them out. So, predict how the graphs of each of the following equations will be the same or different from our kind of our base one of x squared. So 5x squared. Well, let's type in here. So they're both going to be parabolas, right? Because we've got, they both have the x squared in there. And let's think of vertexes in terms of vertexes. So if I put a 0 in for here, it's going to be 0, comma 0. If I put a 0 in for here, it's going to be 0, comma 0. So we'd have our vertex at 0, comma 0. Because anything we do above that, 1 squared, it gets bigger. Negative 1 squared is still going to be 1. 1 squared is, this would be 5 for an answer. Negative 1 squared would also give me 5. So both of those are going to get bigger. Differences, though, this one is going to be increasing faster. So increases faster because this one here was 1 comma 1, here was 1 comma 5. So it's going to increase faster, and then it's going to be skinnier because it's the next point is 5, not 1. So it's going to go faster, quicker. Okay, so this one. This one is, they're both parabolas. If I put a 0 in for here, I don't get 0 for my answer. I get 25. So um, I actually will put on here that we have 0, 25 is a point. We'll figure out if it's definitely a y-intercept, right? Because it's there, but let's see what happens with the vertex. So if I put in a 4, then that would be 9 squared. So that one's getting bigger. What if I put in a 6 or -1? Let's do 1. 1 and -1. Um, or wait, how do I get this to be a 0? That's really what I need to know, is what number will get this to be a 0 so that um, I can see where my vertex is. Because once 0 is going to be my lowest, right? Because 0 squared is going to be 0, and anything else squared is going to be bigger. So I need to know when this inside is going to equal 0. Well, x has to be a -5 to equal 0. So -5 comma 0 is going to be my vertex in this case, because -5 plus 5 is 0, 0 squared is 0. Otherwise, if I do -4, then I have 1 squared, 1. +1 or -6 would be -1 squared, which gets me back to 1. So that's where I start repeating again. All right, so this one is, trying again here, there we go. Both parabolas, we got that in common with a lot of these. Um, Once again, our vertex, I put in a 0, I'm getting 0. So we've got our vertexes at 0, comma 0. Over here, um, it's also kind of like this one in that I'm going to take 5 times 1 and then square it. So 1 times 1 is 5. 5 squared is 25. So here I went from 1 comma 5 to 125. So this increases very fast and even skinnier parabola than the one up here, right? And again, this one, both parabolas. So here, you got to figure out kind of where that vertex, because if I put in 0, I end up with a 5. So if I put over here, so 0, comma 5 is definitely my y-intercept, right? But let's see, if I put in a 1, then I get 6. So that's bigger. If I put in a -1, I get 6. Well, I'm repeating again already, and that's each one around my y-intercept. So this must also be the vertex in this case. All right, so Optima decides to use technology to figure this out, to test these. She thinks it's a good idea to start simple. So she just starts with the y equals x squared plus 5, and with her y equals x squared in the same window. So we'll see this to see what we find. So I've actually already graphed this, pretend like we've used technology. So here we've got the x squared, right? Down here, 0, 0, 1, 1, 2, 4, 3, 9, moving up that way. Here at the x squared plus 5. Notice how everything is just 1 squared plus 5, 2 squared plus 5, 3 squared plus 5. Everything is just 5 higher for the next one. So what we're going to put on here is the first equation's y exponents are all 5 higher than x squared's coordinates. Okay, so all it did was shift everything up 5. So knowing this makes a lot more sense. So she tries a few more examples like x plus 2 and x squared plus 2 and x squared minus 3. Looking at both a table and a graph for each, what conclusion do you draw about the effect of adding or subtracting when you do this? Um, so let's look at these when we're doing it to try to make a general explanation here. So if I'm doing this one, so here's number 5's x squared plus 2. So notice it's plus 2. So I've got my repeats going around that 0, comma 2, and everything is shifted up 2. Here, we have everything shifted up. Let's get that up just a tad. So oh, that just screws up everything else. Never mind. Deal with it. Let's get that down. Oh, there we go. So now here we have that circling down at -3. So I went down 3. And everything is repeating after that. So that -3 is right here showing it's -3 at my y-intercept. Plus 2 shows me how many up or down I'm going. So if we are going to explain why this works, the vertex moves up or down y-axis depending on if you are adding or subtracting from the x squared. So think of this kind of too. You know how we have y equals mx plus b? This plus b is your y-intercept or your up and down. So um, that's how much it's moving up or down on the y-axis. So that kind of is the same idea as over here. It's a plus or minus is affecting the y. All right, let's go ahead and scroll down. So number 6, after her amazing success with addition on the last problem, she decides to look at what happens when you do it inside the parentheses, so before it gets squared. So I'm going to go ahead and highlight that before it gets squared. So using the technology, decide if that plus 2 or sorry, not plus 2, plus h or minus h. So we'll pick some numbers to go in there and see what happens. So let me go ahead and show you what that looks like. So we did a -2 and a +1. So here, if I do a -2, look at that. It shifts everything to the right 2. So I have a +2 as my um, x-intercept now. My vertex has moved to the right 2 to get over here because 2 minus 2 is 0. And that's where I need to get it down to 0. Here, a -1 plus 1 gets it to 0. So that shifts it to the left. So you kind of have that same idea, except inside the parentheses moves it right or left. So let's go ahead and write that down in here. The vertex moves along the x-axis to the number that makes the value in the in parentheses equal 0. So another way to kind of think about it is the x plus h to the second power moves it left, moves the vertex. Let's be detailed. Vertex left. And x minus h to the second power moves the vertex right. H spaces. Let's put that in there. H spaces. So moves to the left, moves to the right. Okay, Optima thought that variable number 6 was very tricky, and so she hopes that multiplication was going to be more straightforward. So she decides to start simple by multiplying by a -1. So she just does y minus x squared, negative x squared. Predict what the effect of the graph and then test it. So let's just go ahead and draw a little graph over here. Let's do a couple of different things. So if I do a 1, 1 squared is 1, so 0 is 0. So we've got that one. 0 is 0. 1 squared is 1, and that would be a -1, right? So that goes on each side. 2 squared is 4, and it would be a -4. So notice what it's doing. 3 would be 9, and a -9. So it actually turns it upside down, right? So um, if we're going to do that, basically the negatives, we'll just do a -2. So this is the negative x squared. What if we do negative 2x squared? Well, 0 would still be 0, but 1 squared is 1 times a -2. It would just make it go farther faster. So this is just a skinnier one in there. So what's happening here is the negative reflects the parabola over the x-axis. Um, since all output values are made negative by the -1. Okay, so that flips it over the x-axis. Okay, so she's encouraged because that one was easy. So she decides to end her investigation for the day by determining the effect of what A does on there, that multiplier. So using both positive and negative numbers, fractions and integers, do at least 4 tables and matching graphs to determine the effect. Again, I'm going to keep it a little bit simpler since I'm doing this on the computer and not in class. If we do, um, I'll do a couple of them here. Do 3. So we'll have our original over here. So this is the x squared. And we know it should be kind of a normal 1, 1, whatever. This is our average. So this would be 0, 1, 1, 4, 4, 9, 9, right? So if we're going to do 2x, we've already done the negative up there, so I'm not going to worry about that one. But the 2x, let's just even do 3. Let's do 3 since we used 2 above. We're still going to have 0, 0, but 1 squared times 3 is going to be 3. It's going to be up here, not down here, but more up here. And it's going to be the same on the other side. 2 squared is 4 times 3 is 12. We are way up here already. So 2, 3, 4, anything like that is going to make it get bigger faster. That's going to be a skinnier one. What about fractions? What if we did 1/2 x squared? Well, 1's kind of messy, so let's just do 2. So 2 squared is 4. Half of 4 is 2. Well, that's going to put it, don't want it quite that high, because 2 is going to be down here. 4 squared is 16. Half of that is 8. Notice how I have to go way out here to kind of get to those. So that's actually going to be a wider, because if I do half of that, they're all going to end up underneath half of whatever this one is. So it's going to be a wider one. So to conclude on here, A affects the stretch of the parabola. If this is would be kind of a weird, well, no, I think we're okay. So if 0 is less than A, which is less than 1, so it's a fraction. This is a fraction. If A is a fraction, then the parabola is wider. if a is greater than 1 or a is less than 0 or less than, let's say, -1, right? Because we want it to be, we said if we had a -2, it was going to make it skinnier. If we had a +3, it was going to make it skinnier. So anything bigger than 1, so it's not a fraction, smaller than -1, so it's not a fraction, will make the parabola skinnier or narrower than x squared. Um, yeah, so there we go. Fractions made it wider. Any of those things make it narrower. And that should be it for today. Thanks for joining us. We'll see you next time.